Blobs in Earth's interior from Ancient Planet. Blobs in the Earth's interior mantle have been puzzling geologists for decades. Find out how a new study solves the mystery by linking them to an ancient planet that collided with Earth to form the Moon. I was living in Ottawa in the late 1980s when the Australian rock band In Excess released the song Never Tear Us Apart. It contains the iconic line, "Two worlds colliding and they will never tear us apart." You probably know the song I mean. What you may not know is that scientists believe that the Earth and the Moon formed when two worlds really did collide in the early solar system. According to this giant impact hypothesis, a Mars-like planet scientists call Theia collided with the young Earth. When the two planets crashed into each other, they spewed material from both of them out into space. This debris, mainly molten rock and metal, started orbiting around the Earth. It gradually coalesced into a single mass and cooled, forming the Moon. This collision with Theia generated intense heat, forming Earth's early atmosphere. The heat also melted the lunar surface, which is why the Moon used to be volcanic. Dr. Qian Wan studies the dynamic processes in Earth's interior. He earned his PhD last year, and he's currently a postdoctoral scholar in geophysics, working in the laboratory of Professor Paul Asimov at the California Institute of Technology, Caltech. Professor Wan has been focusing on the origin, form, and movement of two blobs near the Earth's center, each of which is twice the size of the Moon. One blob is under Africa, and the other one is beneath the Pacific Ocean. One reason Professor Wan is so interested in these blobs is that he believes they're related to the collision between Earth and Theia that created the Moon. He's the lead author of a study on this topic that the journal Nature published earlier this week. The researchers believe that these blobs, called Large Low-Velocity Provinces, LLVPs, are the remains of the planet Theia. The team has concluded that the Earth absorbed most of Theia, which explains why there are no fragments of the ancient planet floating around in the asteroid belt or in meteorites. The blobs came to scientists' attention back in the 1980s, around the time that In Excess was singing about worlds colliding on the radio. When they measured seismic waves traveling through the Earth, they noticed a couple of three-dimensional variations deep in the Earth's internal structure. The seismic readings suggest that the two blobs contain unusually high levels of iron. That makes them denser than the surrounding mantle, which slows seismic waves down. That's where the low velocity comes from in their name. Professor Wan came to this realization while attending a seminar by Professor Mikhail Zolotov of Arizona State University. While discussing the giant impact hypothesis, Professor Zolotov mentioned that the Moon has a very high iron content, and that scientists had never found any trace of the planet Theia. As he was sitting in the audience, Professor Wan put two and two together. Right after Mikhail had said that no one knows where the impactor is now, I had a eureka moment and realized that the iron-rich impactor could have transformed into mantle blocks, he said. Having come to this realization, Professor Wan started collaborating with other scientists from a range of disciplines. Together, the team came up with simulations that confirmed that Theia's collision with Earth would have caused the two mantle blobs and the Moon to form. It appears that Theia had a mantle similar to Earth's, but richer in iron. Theia's mantle would have come into contact with Earth's, where it coalesced into the two thick blobs that have been puzzling geologists. The reason Theia's mantle formed into two blobs is that the upper half of Earth's mantle absorbed most of the impact energy. The lower mantle didn't melt completely, so the blobs held their shape and sunk down almost to the base of the lower mantle. Nothing could tear them apart. Sorry, I couldn't resist. The lower mantle didn't absorb the blobs because of the difference in temperature. Had more of the impact energy reached the lower mantle and heated it, the blobs would have diffused throughout the Earth's mantle. We all want to make sense of the world around us and our place within it. For example, we've all gazed in wonder at the moon from time to time. This discovery, connecting the large, low-velocity provinces in Earth's interior with the giant impact hypothesis, fills in the blanks in an important chapter in the new science-based story we need to come to terms with who we are, where we came from, and where we're going. The scientists now want to learn more about how the blobs hidden deep inside the Earth may have affected the currents in its interior mantle. For example, how do these blobs influence the plate tectonics that cause continental drift and earthquakes? Professor Asimov, who heads the laboratory and is one of the study's co-authors, commented on the discovery, saying, "A logical consequence of the idea that the LLVPs are remnants of Theia is that they are very ancient. It makes sense, therefore, to investigate next what consequences they had for Earth's earliest evolution, such as the onset of subduction before conditions were suitable for modern-style plate tectonics, the formation of the first continents, and the origin of the very oldest surviving terrestrial minerals. We always have more to learn if we dare to know."